Everyone. My name is Jeremiah Lindale. I'll be talking to you guys today about security and object-oriented programming. An overview of what we'll talk about today. Talk about security terms, OOP concepts, as well as applications of these terms. First, let's start out with class. Class is a category of objects, and it defines all the common properties of the different objects that belong to it. Encapsulation. Encapsulation is the process of combining elements to create a new entity. A procedure is a type of encapsulation because it combines a series of computer instructions. Abstraction. The process of picking out or abstracting common features of objects and procedures. Then we have inheritance. Inheritance allows subclasses to use attributes from its parent class. Then we have polymorphism. Polymorphism allows programmers to use methods of the same name but with different objects. And then modularity. This is the extent to which a software/web application may be divided into smaller modules. Software modularity indicates that the number of application modules are capable of serving a specified business domain. Modularity is successful because developers use pre-written code, which saves resources. Next, we'll also talk about domain separation. This allows you to separate data, processes, and administrative tasks into logical groupings called domains. You can then control several aspects of this separation, including which users can see and access data. Layering. Layering is a set of classes that share the same module dependencies with other modules, implying that the layer components are reusable as long as conditions stay the same. These import dependencies between software modules is a way to express layer distinction in a programming language. Clustering. Clustering the task of grouping a set of objects in such a way that objects in the same group or cluster are more similar in some sense to each other than to those in other groups or clusters. It is a main task of exploratory data mining and a common technique for statistical data analysis. Then we have process isolation. Process isolation is a form of data hiding which protects running threads of execution from using each other's memory. Then we'll talk about least privilege, also known as law of Demeter. A given object should assume as little as possible about the structure or properties of anything else, including its subcomponents, in accordance with the principle of information hiding. Then we have open design. Open design, according to this principle, the security architecture and design of a system should be made publicly available. And then data hiding. Data hiding conceals a lower level process or processes from higher level processes. Moving on to simplicity. Simplicity is the lack of complexity that allows system designers and programmers to identify unwanted access paths. Users can easily translate their general protection goals to appropriate system security configurations. Next, we'll talk about minimization. Here, you have the least functionality necessary in a program or device. And then confidentiality. It is an expectation for the entity to be entrusted with data or code to keep it a secret. And then integrity. This is an expectation for the entity entrusted with the data or code to only allow authorized modifications to it. And then availability. This is security actions that ensure the data is accessible to authorized users only. And then information restriction. Information restriction complements information hiding. Instead of hiding certain methods, we make them public, but we restrict their use. And then lastly, we'll talk about structural induction. This basically is the law of Demeter is related to the fundamental thesis of denotional semantics. This is, the meaning of a phrase is a function of the meanings of its immediate constituents. I hope these terms and applications help you become more aware of SUPE terms. Thank you, and if you have any questions, please ask me after the presentation.